So the two topics I found to be most likely to be on the test were area under a curve and the disk method. So define area under a curve, the definition. The definition of area under a curve is the area between a curve and a line such as the x-axis or y equals the number. So it can be a line where they give you the limits, like this, for example, this line right here. Or it could be a graph where the limits are defined by the x-intercepts, like this one. So to find the area under a curve for a line where they give you the intercepts, you just take the integral from the lower intercept to the lower interval to the higher interval of the integral of the line from the lower interval to the higher interval, and for the one where you have to find the x-intercepts, you just take the lower x-intercept to the higher x-intercept. So, for example, we have the second graph, which is negative x squared plus 2. So to solve this, like I said before, take the integral from the lower to the higher x-intercept. So our lower x-intercept we determine by making our y equal to 0, so negative x squared plus 2 equals 0. And then you just solve for x, so you get x equals plus or minus square root of 2. So obviously negative square root of 2 is going to be your lower intercept, and positive square root of 2 is going to be your higher intercept. So as I said before, you take the integral from negative square root of 2 to positive square root of 2 of your original formula, which is negative x squared plus 2. So since this is calculator active, you can just type this into your calculator, and you get 3.7712. So that's how you solve the area under a curve. So now disk method. Disk method is where you find the area of a region when it's rotated around an axis. So our formula for this is volume equals the integral from a to b of pi times f of x squared dx. And this is derived from your area of a circle, because when you rotate your graph around the x-axis, it forms a circle around the axis. But instead of your radius, you have your f of x, because your radius is not necessarily the same throughout your whole disk. So when you are using the disk method, the big thing to remember is to make sure your variable matches the axis of rotation, because your axis isn't necessarily always the x-axis, or and it doesn't always match your original formula. So your original formula might be y equals something, but you might also be rotating around the y-axis, so you need to change your formula into x equals something. But for this example, they match up, so it's not a problem. So this example is the volume enclosed by the x-axis, the formula y equals x to the power of 2, and x equals 3 when you rotate this around the x-axis. So our area, pi r squared, this is how you derive the volume formula. So then our volume equals the integral from 0 to 3 pi, and instead of our radius we have our function squared dx, and then this is just substituting in the function. And since this problem is also calculator active, you just put that into your calculator and you get 48.6 pi units cubed, because you took out your pi in between these two steps. And if you don't have a calculator, you obviously just take the integral of x squared, and take the integral of that at 0 and at 3, and you subtract the integral at 3 from, subtract the integral at 0 from the integral at 3. Either way, you'll get 48.6 pi units cubed. So that's how you do the disk method and the area under a curve.